this is another problem of summing series. Okay, we have this function f of x, but the x here is exponent, right? Is the exponent of this n here, and we want to evaluate f of 0, of 1, and of 2, right? Well, f of 0, of course, is the sum from 1 to infinity of 1 over n factorial, okay? Of 2, oh, sorry, of 1 is equal to the sum from 1 to infinity of n over n factorial, right? And of 2, it is the sum from 1 to infinity of n squared over n factorial. So we have to evaluate these three series, right? Well, to sum them, okay? The closest series that we have to this is the exponential, right? Remember, the exponential is the sum from 0 to infinity x to the n over n factorial. So we have at least this n factorial in the denominator, and with suitable choices of x, we can try to match this series here, right? Okay, so let's focus on this one, f0. Well, clearly, this is equal to this term when x is equal to 1. So, in principle, we have the exponential of 1. But you can see here that the starting point is n equal to 1, not n equal to 0. So we have to subtract the 0th term of this series, which is equal to 1. So actually, this is the value of this series here. So it's e minus 1. All right? Okay, let's go to 1. There are two ways at least to do this series here. Okay. F of 1 is, well, you have n over n factorial. Clearly, the factor n cancels up and down, and then you have 1 over n minus 1 factorial. And if you just shift the indices, so 1 unit down here and 1 unit up here, what you have is the sum from 0 to infinity of 1 over n factorial, which is e, right? It's e to 1 or e. Now it begins at 0, so there's no problem of adding or not the first term, okay? All right, this is one way. There isn't another way yet. You take this series here, right? And then you take the derivative. The derivative of the exponential is, of course, the exponential. But the derivative term by term of this is, well, the derivative of the 0th term is 0 because it's a constant. But the others are n x to the n minus 1 over n factorial, right? From 1, because as I said, the term n equal to 0 disappears because you're multiplying by 0 here. Sorry, because you're taking the derivative of a constant, right? And if you make this series, in this series you make x equal to 1, what you get is the sum from 1 to infinity of n over n factorial, which is precisely the function that you have here, f of 1, right? But that is for x equal to 1, which means this is equal to this for x equal to 1, so that is e. Same answer as before. So either way, you get the same result, right? But this way is better if we want to evaluate the second one, because for the second one, we can take this expression here, and we can take a further derivative of this. Actually, first of all, we're going to shift the index 1 unit here. So we have the sum 1 unit up here in order to get x to the n here, and then 1 unit down here in the limits. So we have the sum from 0 to infinity, and then we have n plus 1 here, right? Times x n over n plus 1 factorial. No, sorry. No, this is not a good way because actually, if you simplify the n plus 1 here and there, you just recover the derivative, but you just recover the expression of the exponential, which makes sense because the derivative of the exponential is just the exponential, okay? So it doesn't make any sense to keep on doing derivatives to calculate that, all right? So let's do something different. What we're going to do is, we're going to cancel one factor here. So we're going to write first this as the sum from 1 to infinity, and then we cancel this factor, and then we have n here over n minus 1 factorial, because one of the n up here has been cancelled with the factor n in the denominator. And if we shift again 1 unit down the index in here in the limit and 1 unit up the index here, what we have is the sum of n plus 1 over n factorial from 0 to infinity, okay? Now, this can be split into two. On the one hand, you have the sum from 0 to infinity of n over n factorial. And on the other hand, you have the sum from 0 to infinity of 1 over n factorial. Now, the fact that we're starting here at 0 is irrelevant, because for n equal to 0, you have here 0. So it doesn't contribute, really. So you just can eliminate the term n equal to 0 and start at 1. Once we realize this, we can see that this is just f of 1. So this is f of 1. And this term here is e. So f2 is f of 1 plus e. Right? F of 1 was e, so f of 2 is equal to 2e. So that's the answer to this problem.